cost estimation using regression method. We'll be using Microsoft Excel because of it's easily available. So what we're trying to do here, we're trying to estimate cost using this regression method. So regression method is simply it uses some independent variables, some x variables to predict y, the dependent variable. In this case, we'll be showing the simple linear regression. So simple is just only one variable, and linear means there is no square term. It's just y equal mx plus b type of situation. So the prediction of the cost y will be based on just one single variable x and no quadratic or upper level term. It's just the linear term. So in this case, in this example, what we are seeing here, let's say we are trying to predict the bicycle cost or price based on their weight. So I have this 80 bicycle data, cost data or price data, and also their weight. So we're going to run the regression using Microsoft Excel and explain all the results, so you know how to use this simple linear regression to predict cost or estimate cost. So here is the data. This is the data you saw in the PowerPoint file, and then you have to have data like this in one column X and one column Y to be able to use that Excel function. So basically you have to go to the data tab and then click on the data analysis tab there, and then regression, click OK, and then select the Y input. So you can just click on Y here once and then hold the shift key, click here again. Then for X variable, you can click here once, scroll up, then hold the shift key, click here again. And also my data has labels, so that's all you need to do. Hit OK and it will produce the results. Now for the presentation convenience, I have copied these three tables. First table is the regression statistics, second is the ANOVA table, third is the coefficient table. I have copied all of them in this PowerPoint just to have a little bit easy. I think it's easy to see and clean. So I have this three table here. Now Excel first give you the output for the regression table, regression statistics. However, it doesn't make any sense if the analysis result is not significant, which you can see from the ANOVA table. If the p-value is less than 0.05, that means the result is significant, indicates that the weight of the bicycle can estimate or predict y significantly. It can predict significantly. That's the only one thing this table can tell. If the p-value is less than 0.05, and which is here. The second table, which is the first table in the Excel output, I don't know why this table does not have any meaning if the model is not significant. So first we'll have to check whether the model is significant or not, which you get it from the ANOVA table. The model is significant, meaning that the X variable weight can predict Y significantly. Second, we have to see these regression statistics. This will tell us that how well it can predict. So we know that weight can predict the cost, but this table will tell us how well it can predict. The first parameter is the R square. That's the one most commonly used to understand how well the regression model is, how well it is performing. So this R square value, 95% or 0.9, indicates that the 95% variation in the price or cost can be explained by the weight of the bicycle. You know, the cost and price can be changed because of so many other factors that can affect the bicycle cost or price. You know, so many stuff can affect it. However, the variable that we are using in this case is we are trying to use the weight of the bicycle to predict the cost, the Y So this is our x variable. So this x variable can explain 95% variation in the cost. So this is a very strong, good prediction model or cost estimation model. The second piece that I want to mention is the multiple R, which is the so in the regression we are trying to actually find the predicted variable y equals something like mx plus b, something like this equation we are trying to find out. So we'll see that in soon. So we are developing some predictive equation for the cost based on the weight, the x variable weight here. Now that predicted value, and we have actual y. So there should be a correlation between these two. This multiple R represents in a simple linear regression that the correlation between y and y hat, the actual value or cost and the predicted cost based on our regression analysis. The correlation between that is multiple R. In a simple linear regression, this multiple R also is the same thing as the correlation between x and y values. So as you can see here, 98% correlation between the predicted value and the actual value, meaning that this is a very strong predictive model or cost estimation model. So we can very confidently predict the bicycle cost based on the weight. Now there are a couple of more statistics, adjusted R squared, standard error, things like that. Now if you're new to regression, you want to know more about regression analysis, you can go to the openeducator.com, and then under design of experiment there is a chapter written on the applied regression. So you can learn on this or kind of refresh your memory if you forget a whole lot of this. So all the stuff needed, for example, under results you can see practical significance. Here I have written the adjusted R square. There is a specific video demonstration for in this section too. If you just for your refresher, you can go to the openeducator.com under DOE chapter 9 applied regression. You can check those out. So let's go back to our original cost estimation model. So this is the third table that you get in Microsoft Excel. This table is the coefficient table. So basically this is the table that gives you the estimated regression equation, which is y hat, which is the intercept $10,386 minus the slope, which is 342 in this case, times the x variable, this. So this is our predictive equation. We can simply predict any cost or any price of a bike simply putting their weight in this equation. For example, let's say we're trying to find a weight of a bike, the cost of a bike that is 20 pounds heavy or 20 pounds. That's, I think I calculated about 3,500 like that. Let me double check that in Excel. So here is, so we can just simply go here, you can type here equal to, so this is equal to this plus 20 times the slope, so about $3,500 for a bike that weighs 20 pounds. So I hope this explained the how to estimate cost or how to predict cost based on the regression method. And basically I think that's all. Thanks for watching.